Hello, good day, everybody. I'm Debesh from India. I'm back again with a tech podcast after a gap of few weeks. So today's episode is a special segment. I call it IIT Bombay Alumni Speak. It is a tech podcast, of course, on a topic, current topic, trending topic. But today's guest is an alumnus of Indian Institute of Technology, Bombay. I'm also an alumnus. Okay, without much ado, let us bring the guest on the screen.
Hello, Debesh. Very good evening and good morning to all of you, based on your location.
Hi, Chitradeep. Massive welcome to the podcast. As I mentioned, this is a special segment called IIT Bombay Alumni Speak. Earlier, 5 episodes we could do with alumni of IIT Bombay. So today's topic is there in the flyer. It is emerging trends of 6G, AI assisted 6G. So without much ado, as I begin, that the guest introduce himself or herself from their mouth, own mouth. So first, please tell us very briefly about who you are and what you do.
Well, currently I am working with Nokia Standards Division and Nokia Bell Labs as a senior research specialist. I am located currently out of Bangalore. Uh, and prior to joining Nokia, I was with Samsung Research, and I joined Samsung somewhere in 2019. Prior to joining Samsung, I was with the University of Liverpool, where I was doing my postdoc. I was a research fellow of the British Royal Society. I was a Newton International Fellow, so my work was primarily in the areas of IoT and data traffic modeling of the IoT, Internet of Things. So before my postdoc, I did my PhD from IIT Bombay from the electrical department in wireless communications engineering. And while I was doing my PhD for 2 years, I was at the University of Tokyo, Japan. I was a MEX research fellow. It was kind of a visiting researcher. So, and I did my master's from UK, from University of Southampton, from the School of ECS, and I had my BTech undergrad in electronics and communication from Calcutta. So this is all about my qualifications and my current professional attributes. And yeah, that's
Okay,
about
thank you very much.
shortly.
So as I also mentioned that you are an wireless communication expert,
Right.
if we say
That's correct.
briefly.
That's correct.
So that is a topic which always being in the public domain, like people are using it for everyday
Right.
communication, and it will improve every day. It is improving, and as from the title that 6G, we are probably using 4G or 5G.
Currently, we are using 4G and 5G both. So it's
5G
kind of,
just
yeah.
started. Yes,
So 5G has started. It's there. It's there for quite some time.
yes,
5G. It's 5G. 6G
yes,
will take some time for commercial rollout. It's still few years to go. It's still in the pre-standardization, very early phases, research study item phase right now. Just in the releases 3GPP, the body which kind of works on the standardization, ITU and 3GPP. It's still at a
yes.
very early stage, but yeah, yes, it will
Yes,
take
but
time.
many of us, like I am using 4G because my smartphone is
Right,
not 5G
right.
device. So many people are still using 4G.
That's correct.
And so before going into your topic, would you please tell us like the communication standards like 2G, 3G, 4G? That
Yes.
is
So if I just explain you in a
yeah,
very
and if
simplified,
please go very slowly so
yes,
that we
sure.
can follow your talking.
Okay, so if I just explain this evolution of generations over the time, over the last two and a half decades, if we remember, somewhere in the early 90s, where in order to make a STD call, it was all landline based phones, and in order to make some STD call or an ISD call, we need to go to the telephone booths, right? And they were really used to be expensive. So at that time, voice call was the only main premise for telecommunication, right? So that, whether it was primarily, it was landline. Then somewhere in the mid 90s, we have seen in India the first cellular communication started with few of the operators, mainly in the metropolitan cities. And then in by early 2000, we have the CDMA and all these technologies. So when by the time when the 3G came into the picture, so at least we were aware, we were of video streaming over the mobile phone. It was not something unknown. On those old Reliance handsets, CDMA handsets, we could stream some of the videos. It was possible. It was not just limited to voice communication. Of course, SMS and textual messages were always there. And then of course it evolved gradually, and the 3G 3 edge and all these technologies came, which was prior to 3G, prior to 4G rather. We were being able to deliver emails, the Blackberries, the secured communications. So there were emails were exchanged, the textual messages. So the scope was increasing. More than the voice communication, now we could have at least the basic multimedia communication. But there was an entire paradigm shift somewhere by 2013 or 2014, when actually the 4G started rolling out in India in a big scale, in a larger scale, especially when the Geo and mobile network operators, Geo and Airtel mainly, they got into the market with their 4G commercial rollout. And then actually in the Indian market, there was a kind of a boom. We have all these services like the Zomato, the Swiggy, the Uber, the Tele. So all these services came into the picture, which was mainly based on the cellular communication. The backbone was the cellular communication was the backbone. The connectivity is the backbone, and naturally, with when the 4G came into the picture by 2014, the entire landscape changed, right? So that was all about the 4G, and with 4G, you had more number of use cases like that of the Swiggy, Zomato, Uber, the radio cabs, and so on. And of course we can now see the YouTube videos and multimedia, high throughput multimedia communications is possible with our just with our cell phone. We can download movies and watch. Now in 5G, the main idea was that there was a three, we call it the three pyramids. There were three main use cases for 5G, which was envisaged earlier. When it started, the research for 5G started somewhere in 2013, 2012, the basics. Now we have the 5G. The cycle is generally for 10 years. The research for 5G started way back in somewhere around 2012, and now almost in Japan, in the first world countries, we had 5G somewhere by 2021, by late 2020. But now in India, we have it somewhere around 2023. The rollout started, right? But the research has started. It's a 10-year, typically a 10-year cycle. So research for 5G has started way back. The study item since release 50 of 3GPP. By the way, 3GPP and ITU are the standardization body which determines whether the cellular communication technology will be 3G, 4G, 5G, 5G advanced, or maybe 6G. These are the standardization bodies, and they determine what are the use cases, what are the technical problems, and the challenges associated with the use cases, what are the potential solutions. And all these solutions are determined by a consensus with all the vendors, operators. There is a consensus. Every year we have multiple meetings of the different working groups of 3GPP, and 3GPP is called the third generation partnership project. So we call it third generation just for the name, but it is the standardization body. It also it's the same body that determines everything, whether it's a 6G, it's just the name 3GPP. We call it the acronym that we use. So this is the body. Every year we have all these over multiple meetings, and in all them in these meetings, different companies, network vendors, UV vendors, the chip vendors, and of course we the operators, everyone they have participate, and there is collectively a consensus is made on different use cases, problems, solutions, and they become a part of the standard. So that's how the standardization process works in general.
Okay.
So in
Uh, uh,
5G, we had the three main use cases. That was ultra reliable, low latency communication, then enhanced mobile broadband, EMBB as we call it. There's a very high throughput. So download speed in the order of 100, 200, 300 Mbps, or maybe even more than that. and of course, last but not the least, my massive machine type communication. So it is, we call it MMTC, massive machine type communication. It's kind of a step beyond IoT. In IoT, we talk about different devices in a localized area. In massive machine type communication, we can extend to a massive number of devices, and these devices are connected with using the cellular protocol. So that was like narrowband IoT, or these kind of in the license band, actually, no, not just limited to unlicensed band, ISM band. So that was the scope. Now, if you allow me to explain more about 6G, then I can explain.
Yes, please, we
Right.
will do it.
Sure.
It is good to see that two-person joined and showed love to us. Like, hello, Ayush Sharda on YouTube. And thank you, Ayush, for joining. And you can write any question afterwards if you wish. Chitradeep will answer. And here is Girish Venugopalan Nair. He is also um, a tech specialist. Presently, not in India, is working in some other country. So, thank you, Girish, for giving your comment. And if you wish to ask any questions or have any suggestions, you please do it. Okay. So, before that, we'll also tell that as Chitradeep and myself, Debesh, we are uh, alumni of IIT Bombay, Indian Institute of Technology Bombay. So presently we are a part of the Kolkata chapter of IIT Bombay Alumni Association, where Chitradeep has taken the responsibility of the secretary. And we are trying to motivate people to join us and to engage in activities, fruitful activities in technology and also social. So with that, we'll go to the next part. Chitradeep, please tell exactly what is the difference, what will be the difference people will see uh, if it is not 4G and it is 5G and it is 6G. I mean, in terms of, say, giving some examples, say, when we um, exchange on video communication or exchanging files.
Okay. From 4G to 5G, the great difference that you will observe mainly is in terms of throughput, the download speed. The speed will matter. So we talk about, as I explained, the three pyramids of 5G. That's that's the EMBB, enhanced mobile broadband experience for the users. So of course, the download speed will be much higher compared to 4G. It will be in the order per user throughput can go as high as up to 200 to 300 megabytes per second. So that's one very straightforward experience that people can have. Apart from that, what 4G never did was the IoT support for the machine type communications. So 5G is envisaged to support machine type communications, massive machine type communications. And on top, of course, 5G is also expected to support URLLC use cases, or that is ultra reliable low latency communication, where the end to end latency is much less. So it's in the order of less than 100 milliseconds, or even and highly reliable, like maybe 4.5 or 9.5 reliability. So that's the kind of order of, we call those kind of communications as URLLC communications, ultra reliable low latency communication. So these were the three main use cases compared to 4G. In 4G, these use cases were not supported, but of course in 5G it is envisaged to be supported, right? So that's the difference between 4G and 5G. And now when you move from 5G to 6G, it is about the fusion of the digital world, the physical world, and the human world. The main objective is the dynamic network connected representation of the real world things in the digital world. That's what we want to achieve in 6G. We will allow the physical world to be replicated, kind of simulated and automated within the digital world. That's the main goal, opening doors to a wealth of new possibilities and for human benefit. So that's the main idea. So this will involve a digital world from being a source of a 2D, two-dimensional experience and information to a focal point of immersive and productive interaction. So give you an example. So right now, previously, maybe 10 or 15 years back, whenever used to go to a supermarket, right? We used to check out for different products that we wanted to purchase, and we used to get it off the shelf and get it in our trolley. That's what we do typically in the Walmart or any of the major departmental store. It was all manual, right? Then we had, now when the 4G came into the picture, or even 5G, we have these online stores where we have all these products are listed. So but it's kind of a 2D. You select on your mobile phone app or whichever the product you need, and then maybe you will be receiving it just like what we have in big basket, right? But in 6G, what we envisage is something kind of a more immersive. Maybe we will have an entire 2D or 3D map of the entire departmental store, and while you enter the departmental store, there will be kind of a 3D rendering of the entire product base that you want. Suppose if you want to procure something or purchase something, you can it will navigate you, your app, the interface that you have on your mobile phone, it will navigate you to that exact point where that product is there. You will find entire information about that product. What is the source of the product? What is the nutritional value of that product? And entire details. That's a new way of immersive shopping that you can, which is kind of an integration of the digital, physical, and the human world together. So that's what 6G is all about. This is just to give you an overview how it will be greatly different. In terms of use cases, there are many use cases which we can't even think of in 5G. To name a few, maybe I will talk about the non-terrestrial communication. For example, you are traveling in a flight at 34,000, 35,000 cruising altitude. You will have an enhanced
Hey,
broadband experience. Right.
Chitradeep, just interruption. There is a request in the comment to speak slowly.
Right.
Somebody wrote that. Uh,
6G architecture.
no, no, no,
Right.
no, not this one. I would request Chitradeep sir to go
Sure.
slightly slower.
Yeah.
Ayush
Sure.
Shraddha requested. Okay,
Sure.
hmm. So speak slowly.
Right. So for the 6G, there are many use cases. The one that example that I mentioned about the departmental store, right? How the digital, physical, and the human world will be now integrated for a more immersive shopping experience. That's a very simplistic experience, right? So that's how it will be different compared to 5G. So what are the use cases, potential use cases that you may think that 5G, that 6G may support? Suppose you are traveling at a very high with high mobility inside an aircraft, traveling at 35,000 feet. Think about absolute very high speed net connectivity inside the flight from LEO satellites. Right, we already have the Starlink is already coming, the Starlink and Amazon Kuiper. It's already there. So non-terrestrial communication, we have integrated communication and sensing. People doesn't even have to wear any devices. Wearables are not required. The radio waves will bounce off your body, and the signals are on the roadside may detect that you are pedestrian is crossing, and that is going to automate the entire traffic signaling process, the signaling logic. So we call that integrated sensing and communication. That's another use case that we will be having. NTN, IS, integrated communication and sensing. There will be digital twins, the entire replica of a factory or a working machine. Which will we will create digitally in the digital world, and it will evolve along with the physical physical timeline. So we call it the digital replica or the digital twin of physical assets. The digital twin is another interesting use case which will require a huge data rate. And that data rate, typically 5G is not expected to support. 6G, of course, definitely. Holographic calls, as
Yes,
Ayush has mentioned about the AR VR extended reality concepts, AR VR XR. So we talk in 5G mainly about the quality of service, right? So in AR VR XR, we have the quality of physical experience, QoPE as we call it. So it's another KPI, key performance indicator that is required. So because everything is now augmented, you have the augmented reality, you have mixed reality, you have virtual reality, and all combined is the extended reality. Already the standardization is ongoing, and then it's an established study item description and work item description in 3GPP. So it's something very interesting.
Yeah.
And there are
Just
many other use cases
uh,
I can talk about.
just just a minute. Let us see the comment. Girish wrote, "I would like to know more about SDN related challenges in 5G and expected challenges in 6G."
Yes. So it's more about the software-defined networking that Shri Girish is asking about. So, firstly, in 6G now, we software defined networking and self-organizing networks. These are some of the aspects of the networking. This is getting too much into the technical details. So, of course, software defined networking is a key component of the cloudification and the virtualization. So, when we talk about the virtualization of the RAN or the cloud native cloud RAN implementation, the cloudification as we talk about, definitely software defined networking will be the key to achieve it. So in 5G, in 6G, it is more about the spectrum that we are going to use for 6G. Initially, we had the thought that maybe we will be using the sub terahertz spectrum, maybe 100 gigahertz or more for 6G, but that turns out not to be the case. The spectrum mainly now, the trend is the companies that we prefer is the FR3, the upper mid band that is being considered for 6G. So in the upper mid band, when we go for the cloudification, what will be the RAN architecture, whether it will be a lean architecture, we have now the open RAN. So there are different aspects of the RAN architecture, the RAN arrangement that will come into the picture, and based on that, how the self-organizing networks and software-defined networking will come into play. That needs to be seen. It's still in the it's extensive work is going on in 3GPP as well as in the Open RAN. We have the RIC, what we call it, the RAN Intelligent Controller. So that's another aspect. So virtualization of the RAN, vRAN, and the cloud RAN. RAN is the radio architecture network RAN. So that's a lot of research is ongoing, and in 6G, I believe that this is going to further. This will play a very crucial role, software-defined networking, because how the disaggregated RAN architecture will be kind of handled with this. So complexity is definitely going to increase, and more of AI, native AI/ML implementation will come into the picture. That's where the AI/ML. I was supposed to talk about the AI/ML. That was the theme of today's talk. And so it is like this. When we talk about AI/ML for 5G and 6G, it is like this. We already have AI/ML, which is a native to the device, native to the network. That is to the RAN, as we call it, radio architecture network. We have AI native AI/ML at the orchestration and management. We have native AI/ML at the core network, right? So all these aspects, like a Venn diagram, things gets complicated in 6G when we have interoperability issues. So maybe between the CS, between the UE, that is the device side, and at the RAN side, we have some overlapping use case. Maybe, for example, channel state information compression, decompression. So these are some of the use cases where efficient AI/ML algorithms needs to be implemented. So interoperability handling, whether the AI/ML model will be trained at the network side or at the device side. So these are some of the open-ended challenges that we are trying to solve here at Nokia. And of course,
And you already touched that. Ayush specifically asked about AR VR concepts. So, have you already given enough, or would you like to add some more?
we are extensively we have our research group, so we are extensively working on AR VR concepts. We are so Now there are some of the use cases like the holographic calls, like so still in the very nascent research stage. So there are it's so maybe perhaps some of the features maybe can go as 6G day one feature, but maybe as we think that all these futuristic use cases with AR XR, that may not be perhaps the day one 6G. It will be perhaps the later stages of 6G. These use cases will come into the picture, but many things. So whether it's a remote telesurgery, so AR VR will play a great role. AR VR in terms of training in education sector, especially remote learning, the remote immersive experience for the students for lectures, right? So these are the kind of different use cases where AR VR can play a big role, and connectivity will be the backbone, obviously. So I believe that we need to support, in order to support these AR VR use cases, a lot of architectural enhancements will be required, and that's what 6G is expected to provide to in the due course of time, when it actually rolls out by the end of 2030. Hopefully, that's the tentative tentative date of 6G commercial
Okay,
pilot.
as your title already mentioned, the AI assisted 6G. So,
Right,
will you give some more about that? Venugopal writes your
right. Firstly,
also
as
into
okay, okay. So, firstly, in the telecommunications
and
space,
please go slowly because I was
right?
already mentioned.
Okay, in the telecommunication space, there are, as I explained, how we categorize AIML use cases. So there are four entities. That is the radio access network (RAN), where you have the base, which is kind of the base station, right? So so here, when I say RAN, it's the CUDU. You see the towers, the telecom towers, right? So the radio units. So they form the part of the radio access network, the RAN. The device is the mobile phone or the tabs that you are using. So then you have the code network where the digital contents are stored, the code network, right? So code network is there at the backbone somewhere in a centralized server from where you actually fetch the data. And last but not the least, you have something called orchestration and management. These are the four core layers of telecommunication infrastructure. And in all of these four of these verticals, there are native AIML implemented use cases, right? That's already there. Now the problem happens, for example, in 6G, when we have interoperability use case. For example, your mobile phone has a Qualcomm Snapdragon chipset, right? And at the base station, you have a Nokia-based solution, for example. And let us assume a use case of channel state information, compression and decompression. Now, you have to, whenever we are talking about any AIML algorithm, it is about, there has to be some training data that needs to be involved, right? And a training corresponding AIML training model, whatever model we may use, whether it's a deep neural network or any kind of neural network, whatever it is. Interoperability is a major concern because the UE side at your mobile phone, Qualcomm is the chipset. So Qualcomm would prefer to implement its own AIML model. And at the network side, suppose it's a Nokia solution, Nokia would prefer to implement its own AIML model. Now, compatibility, that becomes a great problem because it cannot happen that we share a joint AIML training model at the same AIML training model at the device side, at your mobile phone, and also at the network, because whatever AIML model that your mobile phone is using and the one that is used at the base station, Nokia should not reveal its model to Qualcomm and vice versa, right? So interoperability and confidentiality is a very critical concern. That's one part. The data handling and data security, based on the kind of data that you will be used to train your model, from how you are going to obtain the data, how you protect the data integrity. So there are many challenges, but at the same time there are challenges, but there are corresponding solutions. So that's where we come into the picture. We try to come up with different solutions which can efficiently solve these problems of interoperability, and at the same time we ensure that the quality of the output is at par with other deterministic technologies. So yes, there are many problems. So interoperability issue, and where you are going to train your model, that is another part. Because complexity, while training any deep neural network model, the computational complexity is critical. You may train a model, whether it's a one-sided training model, whether you are training your model just at the device side, which is very complex. You can't use your mobile phone to train some complicated AIML model, right? Because you don't have that much computation power. The training mainly should, but sometimes we have to split it. Some computation needs to be done at the UE side, whether it's a beam selection or beam reporting, and some amount of computation needs to be done at the network side. So we call it two-sided model. So at which RAN entity you are going to train your model, where your the data is going to reside, how you take control the hallucinations and other aspects of your training, so of the AIML output. So how you validate and testing of your trained AIML model of neural networks. So these are many layers of challenges are involved, which is there now in 5G Advanced, and the same holds for 6G. So with different increasing use cases, increasing densification of the base stations. So these problems are going to get more complex in 6G, and we would be requiring more efficient AIML techniques. Now, with the advent of LLMs, large language models, and generative AI, so there are another new aspects are also coming into the picture, which I believe in 6G will be widely adopted, especially the generative AI and the LLMs. So that's what we are looking up to. A very interesting future indeed to look up to.
Yes. So this is a very bright future of communication. The power is there and it is improving day by day. So for say normal human beings who just depend on audio communication and maximum video communication between the two persons. So when the service providers will charge more for say they are having more charges for 5G and 6G. So will the common mass get some benefits or they will be by default they will be charged more?
No, this is the plan of monetize, how the companies decide to monetize on 5G or 6G, because it depends a lot on the policy and the strategy. Of course, people would like to pay for some value added services, right? That's the most important part, because if there is no significant enhancement or significant gain in terms of user experience, why people would pay? People would pay only there if there is some gain, whether it is term of great throughput or great latency, a latent enhancement in terms of latency, or enhancement in terms of user experience, more number of use cases, just one device which can handle everything, the entire smart home automation, voice call, and everything all in one go with one mobile device. So those are the kind of user experience that we need to provide. And if we are providing, if the operators or the vendors, they are providing such user experience, definitely they will have their plans of monetization. So how and when it is going to be implemented, it is only the future can tell, and it depends on the monetization policy. But in general, of course, if there is value added services, it has to be paid. There is a price for everything, because all the technology that we are developing, uh, all the technologies which the operators are opting to purchase from the network vendors or the UE vendors, is coming at a price, and it's a circular economy. So somewhere, if they are spending or investing, naturally it has to be there has to the output also they need to also monetize it, right? So monetization is a key. So naturally, at some point, the people, the end users, they will have to pay a price for the enhanced services uh, that the vendors will be providing. So that's how it is. So it will
Yes,
take time.
right, right. And there should be some options like say in the service plans that
Right.
whoever is
Correct.
willing to add that service or without that
Of
service
course.
the
Of course, the
prices should be different.
flexibility should be provided.
The
Everyone
option.
doesn't everyone doesn't require the value added services. If someone is quite happy with what is going on right now, they
Yeah,
are not
like
into
very
need.
old people, they just need
Yes,
to talk.
exactly. So it should be flexible enough.
Yes, and my personal curiosity, all these wireless communications um, between the base stations and other services, do they use fiber optics?
Fiber optic is the backhaul. The backhaul is the basis for the fiber optics between the base stations. So wireless infrastructure is the one that is your mobile phone is having wirelessly with the base station, nearest base station. But after that, after your the signal reaches the base station, the RAN, the CU as we call it, then if it is all with the backhaul. Suppose we are making a call to US from India, so the wireless part will be mainly the communication from my cell phone to the nearest base station. After that is the backhaul that will take mainly the control. Now the backhaul can be wireless if it is a satellite based call, because from the nearest base station, terrestrial base station, it may communicate with the satellite, the LEO satellite, and that may be connected to another remote gateway which is there in US, something like that. So it can be wireless backhaul, but generally backhaul is fiber optic backhaul. So backhaul will be fiber optic, still physical fiber optic.
Okay, one comment from Girish. Thank you. How can freshers get a job in this domain? What skills are required as a fresher? Any suggested roadmap?
So firstly, I would commend that if the freshers they want to get into the telecommunication domain, at least the basics of the fundamentals of signal processing, digital communication, analog communication needs to be very clear. That's one part of it. The second part is the programming skills are important, because in order to come up with link level simulators or system level simulators, uh, of course, people do code in MATLAB, so that's fine. That's perfectly fine for projects for rapid analysis and rapid prototyping. But of course, in C++ or Python, they are the main simulation platforms or the language that people use to come up with link level simulators or system level simulators, even for machine learning. So Python is the base, right? So they use Python for the all the libraries, connecting to the libraries and so on. So Python and some of the programming languages that needs to be, and of course, last but not the least, domain specific knowledge. Some of the topics like random process, advanced topics, they need to have you need to have a very good idea of linear algebra, because when you talk about radio level modeling, the MIMO, multiple input multiple output, and these technologies, it requires a good understanding of linear algebra, because all those mathematical equations, and they are all linear algebra is the basis, so they need to have very good idea. And of course, with these fundamentals clear, you can approach the telecom companies, and as and when opportunities to come up, I'm sure people will evaluate, and the companies will evaluate. Freshers can get suitable opportunities in these telecom companies. It's possible.
Yes. And are there any free courses available from, say, Nokia and other companies? Do you
There
know?
are not from Nokia. Nokia, we have our internal learning and development hub, but that's for the internal for the employees. But there are some very good external courses available at the external platforms, especially in these days, especially for AIML, for the machine learning. So it's always good, and mostly, and for the domain specific knowledge on wireless communication, the NPTEL lectures from
Yes.
where you have freely available lectures from the renowned, eminent IIT professors. So
Yes.
one can follow those lectures to uh, to to solidify the base, because base and the foundation is very important, especially for these domain specific topics on wireless communication. So I believe that they are the best. The quality is really world class for some of these lectures available in the YouTube, right? So students must follow as fresher these lectures very thoroughly. That will provide them a very strong foundational base on the topic, and then of course they can brush up and they can enhance their skills in machine learning and coding, and that should be the way forward.
And what is the future of the landline telephones? Still, they are running in our country and many other countries.
Maybe for secured communication in the defense and the government sector, maybe that will be important. But landline, the relevance of landline telephone is somewhat, the scope is limited. I won't say that it will be completely, it will vanish in the next 10 years, because every technology has some requirement, especially for secure, highly secured communication, the hotlines that we have for the bureaucratic communication, or
channel.
for the military communications, especially for the defense in the sensitive areas. So where wireless is kind of susceptible or vulnerable to interception or eavesdropping. So in those cases, basic landline communication may be the way, and it will not vanish. It will be there for sure. Landline will be relevant, especially for secured communication and for the defense, tactical
So,
communication.
so it is a very bright future because it is, and 6G as the standards number is coming.
Right.
So, when the next number will start in the project, means is there any, like
Mm.
it is already in the line of improvement. So 5G, 6G. So, were there any talk about another further projects?
Generation.
Gener-
For you mean the
generation.
7G for the next generation?
As any talk is there in internally.
No, not in the standardization body, because the companies right now they are still struggling to monetize 5G itself. 6G is at the corner. Research is almost done. That the pre-standardization work has already started. Now, right now in 3GPP, we will be starting release 20, where the basic study item on 6G will be kind of finalized by the companies in the next few months, right? So 7G has not yet been discussed. It's absolutely not, because the companies are yet to completely monetize their 5G deployment. 6G is on the corner. But right
Okay.
now, no discussion on 7G. There, I can see one question from Soham
Yes.
Sengupta. So he has asked,
Okay. Yes.
recently a news hit the media that scientists in Japan have hit petabyte per second. Is there anything you want to harness in this regard? These kind of technologies, especially like that of orbital angular momentum (OAM) multiplexing, they can provide very high throughput, right? Because they are using different modes. The same wave can have multimodal communication. Four modes. They are using circular polarized waves. So these are very high tech. It's a very high tech, state of the art technology. For example, orbital angular momentum (OAM) multiplexing. So it can achieve huge data rate, but in the standardization right now in 6G, there is no discussion for these technologies. So these are at ideal lab scale implementation, or for the demo purpose, or for a demo POC it has achieved. So when we talk about wide scale deployment of such a technology, it is far. Of course, it's not. I'm not saying that it's impossible, but it will take time. So these are what you see, Soham, that this petabyte per second based on some technologies like OAM or OTFS. So these are not yet standardized in 3GPP. We are not even discussing that. So maybe somewhere during the later stages of 6G, these topics are going to come up. There will be a study item that will be agreed upon by the different companies, and then once they agree, they will see the potential, because in a lab setup, just showing a petabyte per second throughput is great. Of course, from the research community point of view, it's great to have the publication and journals based on these results, experimental demonstrations. But when for the industry, these are just results, and and kind of adopting these technology for mass scale deployment is a different game altogether. So uh, whether we want to harness on in this regard as a company, I think it will take long time. I cannot give you a concrete response to it right at this moment. We have to evaluate, we have to analyze, then we have to see where there are a lot of things involved in this. If I just explain you.
And there is another comment
Another,
from no,
Ayush,
okay, no,
answer my.
From Girish. Any research opportunities for collaboration between private sector and academia? It is already there, isn't?
It is already in place. We know, at least we at Nokia, we are having a collaboration with IISc Bangalore and with the IITs. We have Nokia internationally. We have collaborations with TUM. We have a huge list of collaborations in US. The Bell Labs is in all. is collaborating with almost all the Ivy League universities. In Europe, we have collaboration with the University of Oulu in Finland, with the TUM, Technical University of Munich. In India, we have collaboration with IITs and IICs. We are having an extensive collaboration.
Okay.
There is
So
one question from Ayush. Please answer.
now
So,
I please answer
can,
my question as well, sir.
so
And
which
yes, we
one?
already that
Which
already you have given that
idea of 6G and AR/VR? Yes. So,
already
for that,
given.
yes, the AR/VR concepts already the standardization. It's an established study item. As I said, it's not just in general wireless communication. We talk about quality of experience, while in AR/VR, XR, the quality of physical experience (PQO, PE) is also important, right? So that's there are different architectural enhancements that are required to support AR/VR applications. That's already ongoing. So maybe we can sync up offline if you want to know more about the different enhancements that's taking place in AR, VR, XR. I can direct you to some of the technical specifications and TRs from 3GPP to give you an overview of where the standardization on AR, VR is currently taking, how the direction to where it is going at this point of time. So that's it.
Okay, thanks, Shoham, for the question. Okay, so it is nice going with the comments and answering, and also you have given the brief. All, I mean, I should say not brief, quite detailed about the AI assisted 6G future. And any other notable points you wish to mention, which might be um, very relevant on this?
Yes, the only relevant point that I would like to say is something like this, that the AI revolution is ongoing, and the 6G still we have another 4 to 5 years to go. And you can expect a lot of changes, a lot of dynamic changes in this domain. So by the time when you have actual rollout of 6G, what I have explained today, there can be much more use cases. So that's one optimist on an optimistic note. I would like to end my talk on 6G, 6G AI assisted 6G. There can be more. There is still some time, and within this time, there can be many changes because the industry, the landscape is very dynamic at this point of time. The entire ecosystem is thriving on the boom of AI/ML at this point of time, especially with the advent of large language models, LLMs, and generative AI, which is taking a lot of. And on top of that, there is something also coming up, which is called an agentic AI. So
Yes.
different agents, the designing of the agents. So agentic AI is now kind of a boom which is taking place, and when this agentic AI will come into the will be, when it will be integrated with 6G, so it is going to bring some really disruptive changes, disruptive ideas that was going to propel 6G to new heights. So we have this time. We have to closely observe how the agentic AI shapes up in the next 1 to 1.5 years, and then maybe I will be in a better situation to give you a holistic overview of what 6G will be exactly like after 4 to 5 years from now.
Okay, thank you so much, Chitradeep, for agreeing to appear live. Uh, Many people they don't like to speak live, so that is a courage, of course. And people who joined with comments, we also thank them. And at the end, we mentioned that this is a special segment of the technology podcast. We call it IIT Bombay Alumni Speak, and we'll continue with this IIT Bombay Alumni Speak in more episodes. And as we mentioned that we are a part of the Kolkata chapter of the IIT Bombay Alumni Association, where Chitradeep, I, and many other people are there. So we'll be having many online and offline activities, so which will be notified on LinkedIn, YouTube, and other spaces. So please join our communication here and elsewhere. So with that, we'll say goodbye for now. Thank you so much again. So if you want to add any other sentence before ending, Chitradeep?
I, I want to thank you, Debesh, and thanks all the audience for all the interesting questions. So it has been a very lively and interactive session. I thank everyone for joining this podcast, and I hope to interact with each one of you in the due course of time. Please feel free to add me in LinkedIn, and if you have any further queries, I would be more than happy to get in touch.
Yes, you should join Chitradeep's LinkedIn. So connect with him and get more insights about this topic. So with that, we'll end.